Hello, and welcome to our chapter on exponential and logarithm functions. This first section is going to be about exponential functions and how it works and a few graphs. And I hope you're ready to go. Okay, get your notes out and let's go. All right, our exponential functions, we're going to evaluate exponential functions. We're going to graph them. We're going to evaluate a base E, which is on your calculator. So make sure you have your calculator out. You will need it. And compound interest formulas. So how do you make money? So let's go. All right, first of all, we're going to learn how to write an exponential function. So an exponential function means your base is a number, and then your exponent is a variable. So this either grows or decays exponentially. In other words, y equals b to the x, or some number. So here's an example. We have f of x equals 42.2 times 1.56 to the x. Here, 1.56 is our base, and x is our exponents. Since our base is a number, this is an exponential function. All right, now we just need to know if it's growth or decay. Well, if it's bigger than 1, it's going to be growth. So it's going to look something like so. All right, this is the average amount spent in dollars at a shopping mall. So we have f of x equals the 42.2 times 1.56 to the x power. We know that f of x is money spent at a shopping mall after x hours, so we know x equals hours. Okay, what's the average amount spent to the nearest dollar after 3 hours? So now we have to find dollars when x equals 3. So we're finding f of 3. You need your calculator to do this because you're just going to type it in. So you're going to hit 42.2. You're going to do 1.56 to the third power. All right, some of your calculators, you will have to do this, 1.56. You'll have to do the caret and then put a 3 here. That will get you to the third power. All right, type that in and you should have got roughly $160. And since it said nearest dollar, we are not going to do the cents, and they're going to spend roughly $160 if they spend 3 hours in the mall. All right, pause and do yours. Okay, now when you're read, in 1986, this is when Chernobyl nuclear power plant in the former Soviet Union sent 1,000 kilograms of radioactive cesium into the atmosphere. So this is the nuclear bomb. I'm hoping you remember this. So in 1986, we put 1,000 kilograms into the atmosphere, or the Soviet Union did. So we have the function f of x is representing this 0.5 x over 30. So this is how it decays. The amount of cesium remained x years after 1986. Now, if even 100 kilograms remains, the area is unsafe, so you can't live there. So we know 100 is bad. Will it be safe for humans in 2066? This is 80 years after the explosion. We know x is our years from right here. Should have written that down. So we're now going to plug in 80 here. So f of 80, so 80 years after they've done this, can people live there? So I put 0.5, 80 over 30. You need your calculator. When you're doing this one, if you do the 0.5 to them, make sure you use parentheses. 80 divided by 30, so you get the right answer. Okay, when you plug that in, f of 80 is equal to 157.49 kilograms. All right, it said 100 was safe. This is still over. It is still not safe. You cannot live there and live anyway. Okay, I hope you're doing well. Okay, let's go on here. Now we're going to graph. You also need your calculator, maybe. Okay, so now we're going to plug in, we're going to graph 3x. This is a parent graph. All right, so this is a parent, and then we're going to move it. Well, 3 to the negative 2. Now, if you remember, 3 to the negative 2 means it needs to be in the denominator, so that's 1 over 3 squared, which is, I suppose we could write that out, 1/9. Okay, negative 1 means 1 over 3, or 1/3. Anything to the 0 power is 1. Anything to the first power is itself. And then 3 squared is 9. Okay, let's graph these. Negative 2 is 1/9. Negative 1 is 1/3. 0 is 1. 1 is 3. And 2 is 9. Okay, no matter how small we get, it will never ever equal 0, right? So we have an asymptote right here on the x-axis. So your asymptote is actually y equals 0, or you could write x-axis, both are correct. Your domain, so what can x be? Well, I can plug in any number for x. It may get close to 0, but it's still any number. Negative infinity, infinity, well, your range is what your y can be, and my y starts at 0 and goes on forever. So 0 to infinity. Okay, there's your parent graph. Now we want to move your parent graph, and it moves just like before. So now we have x minus 1 is attached, correct? So remember that moves opposite of what it says, so we're going to move x equals a positive 1, so we're going to move 1 to the right. So you're going to take every point up here, and you're going to move it 1 to the right. Well, if you look at this, so our negative 1/9 is now going to be at negative 1. Our 1/3 is going to be at 0. Our 1 is now going to be at 1. Our 3 is now going to be at 2. And our 9 is now going to be at 3. We moved everybody 1 to the right. Well, moving 1 to the right does not change your asymptote. So it's still on the x-axis, or y equals 0. So your domain did not change. X is still the same. I still have negative infinity, infinity, and neither did your range. Still 0 to positive infinity. Plus 4 is a little bit different. Let's change colors up here. All right, plus 4 means it moves up 4. Remember, it's not attached with the x, so we are going to move up 4. So the first thing we're going to move is moves our asymptote to 4. So instead of being at 0, it's going to be 4. Now, we knew at negative 2, we are at a 9th, so we are at a 1/9 above our asymptote, 1/3 above our asymptote, 1 above our asymptote, 3 above our asymptote, and then at 2, we are 9 above our asymptote. I cannot read these numbers. Hopefully that's 9. All right, we're going to draw in our graph. So now we have shifted up 4. Now your domain, still the same. X has not changed. So we are still negative infinity to positive infinity. Our range now, though, starts to have the value where the asymptote is. So it goes from 4 to infinity. So our range has shifted. Okay, now let's put them all together. So we want to go up 4, right 1. Okay, so we've already moved up 4 with the red one. Now we got to move right 1. Or you could take the black one and move up 4. It doesn't matter. You're going to get to the same spots. So we have here, here. I'm moving everybody right 1. And we draw in our new graph, which is the double move. Okay, when we look at this, our domain is still the same. Negative infinity to infinity. Our range now is still starting at 4 to infinity. Okay, I hope you've done well. Let's try yours. Okay, graph your parent graph, and then we're going to move it. So pause and do your problem. Okay, this is a 1/2 graph. Oh, I should have mentioned up here. I am sorry. Is this a growth or a decay graph? And the answer is it's a growth because it starts low and goes high. So this is a growth. Okay, next one. Okay, so you're plugging in 1/2 into your table. If you know what it is without a table, that would make me extremely happy. So -2, -1, 0, 1, 2. We'll do the first one out and the rest will go from there. So this means 1/2 to the -2nd power. Well, that means I'm flipping everybody, right? 2 over 1, and then I'm going to square it, which means that is 4. So the -1 power, this would be 2. Anything to the 0 power is 1. 1/2, and then square everybody 1/4. So now we're going to do -2 is now 4. -1 is now 2. 0 is still 1. 1/2, 1/4. See how we have kind of flipped over the y-axis? That's kind of what's happened here. This is a decay graph. As it is going down, we still have an asymptote on the x-axis. So y equals 0. We can still plug in any number for x that we want. And our range is starting at 0 to infinity again. All right, pause and do your shifts now. So this one here is attached with the x, so we're going to do opposite. So we're going to move left 2. So you took every point and you moved it left 2. So this was at 2, it's going to be here, 1's going to be here, 1/2, and 1/4. So, oh, I just moved it right too. What was I thinking? Don't do silly things like that, okay? All right, let's try it again. Maybe if it will erase. There we go. All right, left 2. So here we're at 4, we're going to go left 2. At 2, we're going to go left 2. 1 is left 2. 1/2 left 2. 1/4 left 2. And there is my new graph. All right, asymptote's still the same. It's still approaching 0. And x can still be anything. Negative infinity to infinity, 0 to infinity. Okay, next one, you should have went down 3. So you're going to take, and the first thing we're going to do is move this asymptote down 3. So at -2, we were at 4. So we're going to take 4 and go down 3. We were at 2, down 3. We were at 1, down 3. 1/2, down 3, and 4. And there is our new graph. Not much has changed. Domain is still negative infinity to infinity, but now our range starts at our asymptote, which is -3 and goes up forever. Our asymptote is now y equals -3 because we moved down. All right, you're looking here. They still have horizontal asymptotes at 0. Remember, if it's greater than 1, it is a growth. And if it's less than 1, it is decay. And positive, because it's a negative, it's going to flip it again, and you're going to get another growth graph. Base E. If you put e to the first on your calculator, which you do have that button, it's by the natural log button. So you're looking at your LN button. Above it, it should have an E. So when you plug that in, you get 2.718, blah, 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 right? Approximately 2.72 is E. So we're going to use tables and graph this function. So let's do -2, -1, 0, 1, 2. We're going to do e to the x. And when you type all of those in, hang on, I gotta get my calculator. Okay, e to the -2nd. So you're just typing this in the calculator. And we're going to go to the 10th spot. So you get 1/4. E to the -1st is 0.37. Anything to the 0 power is 1. Okay, 2.72 for e to the 1st. And 7.38 for e squared. So let's graph these. -2, almost on the 0. -1, a little over a third. 1, 2.72, and, whoa, my 7 disappeared. Weird. And 7.38. Okay, graph it in. As you can see, E is a growth graph. And our asymptote is still y equals 0. Our domain, x can be anything. And our range starts at 0 to infinity. These work just like x's. There's nothing else with our bases. So this here is going to move left 3. So we're going to take all of our things and move them left 3. So our 0.14 is going to go 1, 2, 3 over. Our here is going to go 1, 2, 3 over. Our 1 is going to go 1, 2, 3 over. our 2.72 is 1, 2, 3 over, then our 7.38, 2, 3 over, and graph in your shift. Still have your asymptote at x equals 0, or y equals 0. Your domain x can still be anything, and your range is still starting at 0. This time, we're going to take our graph. It's -2, not attached with the x, so it's going to go down 2. So now our range is going to change. So now we're going to go down 2 and put in our new asymptote. Now we're going to move every point down 2. So 1 was down 2, point almost a third down 2, the point 1 down 2. We're going to go 2.72 down 2, and 7.38 down 2. Draw in your transformation. And our asymptotes are still negative. Oh, sorry, that was wrong. Your asymptote is still y equals 0. Your domain is still -infinity to infinity. That's terrible, infinity. And 0 to, whoops, sorry, -2 to infinity here. Got carried away. Do that again. So our range is starting at -2 to infinity, and we're good to go. All right, now you're doing a double move. So you know you have to move left 3 and down 2. Doesn't matter which one of the following graphs you've already used. So I could do these graphs and just move them down 2. So it'd be here, 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 1, 2, here, and 1, 2, here. And this is my double move. I can't find my pen. Here it goes. So the green is both moves put together. Your asymptote is still y equals -2. Your domain is still -infinity to infinity. And your range starts at -2. Oh, there it goes. Come on. Sorry about that. My computer glitched out, but we should be all right. So now your range is starting at -2 to positive infinity. That's where our asymptote is, and we move up. Okay, I hope you did well. All right, let's go here. Compound interest, some of my favorite formulas. All right, T is always years, A is your ending balance, P is your principal, this is where you start, like how much money do you start to put in, interest is what you're earning, and N is compounding periods per year. So if it says semi-annually, it means 2. If it says quarterly, that means 4. If it says monthly, that means 12. Those are the 3 main ones, just so you're aware. Annually is just 1. So when you're here, if it's compounding periods, so it gives you how many times it's going to do, it's A equals P, 1 plus R over N NT. This one was amazing. Because what it does is it takes your interest, divides it by how many times you're going to get your interest, because you only get your interest over the whole year. So this divides that out, and then you get paid NT times. This one here is continuously. We don't get this very often in real life. So continuously, your money's earning interest, like all the time. It's not put into your account every certain amount of times. So we like continuously, but that's not going to happen. That's more for like your science and your radioactive materials and things. Okay, the sum of $10,000. So let's write this down. P is 10,000 because that's what we're starting off, our principal. Interest at an annual rate of 8%. So our interest rate, we put that into a decimal form. Find the balance in the account after 5 years. So I know T is equal to 5, subject to quarterly compounding. So N stands for how many times it's compounded, and it is 4 times. So it's compounded quarterly. We're using the A equals P times 1 plus R over N to the NT power. Continuously, let's say compounding continuously. Now we just plug in our numbers. So A is equal to 10,000, 1 plus 0.08 over 4 to the 4 times 5 power. Type that into your calculator, and you should have gotten $14,859.47, because it's money. You better have your cents on there, right? Okay, now let's go to the next one. And it says almost the same problem, but now it says compounding continuously. So that means we're equal, A equals PE to the RT power. All right, again, this is P, this is R, and this is T. So you know A is equal to 10,000 times E to the 0.08 times 5. Type that into your calculator and you should get $14,918.24. So which bank is better? Of course, it's the second bank. We got more money. Subtract the two, and how much more money did I actually make? $58.78 over 5 years. Not a huge amount, but at least it's mine instead of the bank's. All right, good luck on your homework. I hope you do well. And some of you have different homework pages depending on which book you got here.